In this video, we are going to design and evaluate microservice architecture with API gateway design. So before we start, we should always ask ourselves what we have in our design toolbox and what we have learned so far. We write down the functional and non-functional requirements, which are the same, and we are following the microservice architectures. And now we will learn microservice communications and communication patterns. So in the last section, we have learned HTTP based RESTful APIs, GraphQL, gRPC and WebSocket. These are the communication basics and protocols. And in this section, we have learned gateway routing pattern, gateway aggregation pattern, gateway offloading pattern, and API gateway pattern. So now we can refactor our architecture with newly learning pattern and principles. Here you can see the final architecture design for our e-commerce application, which is applying microservice architecture with API gateways. So we basically select 4 main microservices: product, shopping cart, discount and ordering. And now we have added the API gateway between the client and backend microservices using the API gateway pattern. API gateway handles the client requests and route the internal microservices and provides reverse proxy to redirect requests to the internal microservices. Also, API gateway provides an abstraction over the backend microservices. API gateway can also aggregate multiple internal microservices into single client requests. With this approach, the client application sends a single request to the API gateway, and after that API gateway dispatches the request several internal microservices and then aggregates the results and send back to client application in one single response. This will reduce the chatterness communication between the client and backend microservices. And of course, API gateway also implements cross-cutting concerns. That means we can handle the authentication, authorization, service discovery, response caching, retry policies, rate limiting, routing, load balancing, logging, monitoring, tracing, and API allow listing. These kind of cross-cutting concerns can be handled in API gateway. As you can see that we have added the single API gateway in our application. Now it is time to evaluate this current architecture. When we evaluate any architecture, we write down the benefits and drawbacks of current architecture. So as a benefits, we can say that it provides reverse proxy, routing, aggregation, and abstraction from the backend microservices, reduces chatterness network traffic, and implements cross-cutting concerns. So as a drawbacks, single API gateway can become single point of failure risk. And also, business complexity will be increased in one single API gateway. And also we can say that if not scale out, API gateway can become a bottleneck on network traffic. So these are the important drawbacks when using a single API gateway. We should be careful about these drawbacks, because if we put here a single API gateway, that means it is possible to single point of failure risk. And if this client application increase or adding more logic into business complexity in the API gateway, it will be anti-pattern. That means it will become a service-oriented architecture ESP layers. So we can say that API gateway service can be growing and evolving based on many different requirements from the client applications. That's why the best practice is splitting the API gateway in multiple services or multiple smaller API gateways. In summary, we need to be careful about using single API gateway. It should be segregated based on business boundaries of the client applications and not be a single aggregator for all internal microservices.